Why only 68 students today? Okay, more students are joining. So we are done with sliding contact friction bearing, or in other words, what we call as hydrodynamic lubrication, or the journal bearing. Essentially, which is designed more for the radial loads and less for axial loads. Whereas now we'll talk about this rolling contact bearings, also known as anti-friction bearing, which are more common, which are used for a wide range of applications. The simplest being from a fan to any kind of shaft in your bicycles, in your automobiles, two-wheelers, in various purposes, since this comes in the form of an assembly. So we'll be talking about anti-friction bearing. In general, what the common name is the ball bearing and the roller bearing, where the contact is the rolling contact as against the sliding contact, wherein one cylinder is inside the another cylinder hole in case of journal bearing. So let's start with this anti-friction bearing or the rolling contact bearing. My slides are visible and this image is clearly visible to you all, right? Yes or no? Yes, okay. So you can see an assembly of a ball bearing where there's an inner race and then there's an outer race. And between these two races, there are rollers. And the rollers are not free to move in all possible direction, but they are only allowed to roll. And the two bearings are not in direct, the two balls or the two rollers, they are not in direct contact with each other, but instead they are placed inside the cage. So this is the cage, as you can see. So this cage is also known as separator, which are avoiding the contact of a ball to ball or a roller to roller. And all these rollers, they have mirror finish. So they are highly smooth with very high level of surface finish. And we call this as mirror surface finish. Since we are looking for absolutely no friction which is not possible, but minimum possible friction. And so we are also calling these bearings as anti-friction bearing. Are these grooves visible to you? These grooves on the inner surface of the outer race and likewise the outer surface of the inner race. Are these grooves visible? What is the shape of the groove here? What is the shape of the groove that you can see? So here these grooves, yeah, so in the form of arch. So these grooves are curvilinear or in the form of a curve. It's not a flat surface. And because of the curvilinear grooves, it is allowing larger contact area. It is permitting larger area of contact. And what happens when the area of contact improves or increases? Why we are trying to increase this contact area here? To decrease the stress. And because the strength is known, so this is the maximum stress it can withstand, this will permit the larger loads to be transferred. So this permits larger or heavier loads because then the stress would be less. For the same amount of load, if this area of contact is small, then the stresses would be too high. The radius of the groove is different from the radius of the ball. And which one do you think would be greater? Radius of the groove is different from radius of the ball, and which one should be greater? So yes, you are right. The radius of the groove is larger than the radius of the ball. And the reason? Why so? Yes, it is allowing little clearance. It is allowing for some play. So there is a radial play. Ball can roll. Yeah, fitting assembly part, we are coming into it. So it is allowing a little amount of radial play. Plus, this outer race is in a contact with one rotating part, inner race is in contact with another shaft. So if there is slight amount of misalignment, then this play or this difference between the radius, this will take into account that little amount of misalignment. So it accounts for or it adjusts the misalignment between the two rotating parts. That is another advantage of having a larger groove radius as compared to the radius of the ball. So as shown in the figure, this one is the simplest kind of deep groove ball bearing. Now we are talking about various types of ball bearing. We'll discuss about various types of ball bearing, roller bearing, and then we'll compare a journal bearing and a ball bearing. What are the advantages of one over other? So there are different types of ball bearings. The most commonly used, the one which is shown in the picture above, is a single row deep groove ball bearing. We'll be again referring both the design data books because a lot of data is given in PhD design data book for different types of ball bearing. The most commonly used ball bearing, normally designed to take the radial load coming along the radius of the shaft. It can also take axial load to some extent, but only when these axial loads are smaller than the radial load. If they're equal to radial load, they're greater than the axial load is greater than radial load, then we have to go for other type of ball bearing. But this single row deep groove ball bearing, as I said, the one that is shown in this image, this one is used essentially for radial loads. What if the axial load is greater than the radial load? If the axial load happens to be greater than or equal to radial load, then we go for a different type of ball bearing, which is known as angular contact ball bearing. Angular contact ball bearing. So these are the ones which are designed for larger axial loads. Why so? It is because of its design. Yes, I have the image. Yeah. This is the angular contact ball bearing. And how this is different, if I draw a side view of this bearing. The grooves are cut like this, and the ball is placed here, and line of contact is something like this. Similarly, on the other side, again, grooves are like this. This is the line of contact. Here you can see this. This is known as line of contact. So it's because of its design that this can take the axial load and this can take the radial load both, this being the line of contact. So the resultant happens to be along somewhere close to this line of contact, because of which it can sustain both kind of load. Now, depending upon what is our assembly, we have to select the type of bearing. If it is only radial load, pure radial load, we can go with deep groove ball bearing. If there are axial loads much less than radial load, we can still go with deep groove ball bearing. But if we find out that the axial load is coming out to be greater than radial load, we have to go with this angular contact ball bearing. Again a ball. A little modification in, yes, a little modification in a single row deep groove ball bearing is, if the radial loads are very high or large or heavy loads, a single row of ball bearing might not be sufficient to withstand the load. There we use ball bearing. So instead of a single row, there will be 2 rows of ball bearing. So this is known as a double row deep glue ball bearing because this will allow larger radial loads to withstand. Now, if there are machines with lot of vibrations, and there are machines in factories, in industries with heavy vibration, with lot of load coming in multi-axial direction, and there's a chance that the shaft is continuously getting misaligned. You know what is the meaning of alignment or misalignment? If this is one shaft, and if this is another shaft, you cannot have a shaft of infinite length. So somewhere you have to couple these two shafts. So couplings are used. I'm sure you have studied about the couplings in what? Machine drawing? Have you studied about couplings in machine drawing? Otherwise, we'll have to quickly go through the types of couplings. Remind me after this topic, anti-friction bearing, we'll talk about different types of couplings. So you haven't studied, right? Machine drawing? Have you, Prajwal? Have you studied about machine couplings, different types of couplings? Little bit, okay. Okay, so we need to cover this topic again here. So a misalignment in the shaft is if both these shafts, they must have their axes coinciding ideally. If one of the shaft, this is an exaggerated view, is having this kind of alignment, this is another shaft with this kind of alignment, this will lead to heavy vibrations and shocks because of the misalignment. The misalignment can be in this angular plane, it can be in a horizontal plane or a vertical plane. So if one of the shaft is slightly above the another shaft, so this is one shaft and this is another shaft, these are also misaligned. There is a vertical misalignment. Likewise, on the horizontal plane, if I am looking from the front, I see that they are perfectly aligned. But when I see from the top, I see that the axes, they are not coinciding, they are not coaxial. So there can be vertical misalignment, horizontal misalignment, or angular misalignment as well. So any kind of misalignment will lead to very heavy shocks, vibrations, stresses, and ultimately leading to failure of the machine. So normally we either use universal coupling, which can take little misalignment into consideration, or if a measured amount of misalignment is there, then Oldham coupling is used. You remember having studied Oldham coupling in theory of machines? Saurabh? Sarthak? Arshini? Why no one is answering? You haven't studied about Oldham coupling? Yeah, double slider crank, third inversion. Are you sure you have not studied Oldham coupling? Vaishnavi? Yes, no. Yes, you have studied. Or yes, not studied. You have studied. Okay, you're done. So that will also take into account. Studied but forgotten. Oh, that's a wonderful answer. That's a rather truthful answer. कितने साल पहले पढ़ा था सौरभ? Last year, right? Second year. Saurabh? Yeah, second year. This is third year. So third, fourth, fifth, sixth, 4 semesters, although, but only 1 year, 1.5 years at the most. And that too was taught by Thorat sir. How can you forget it? Anyway, so we are talking about this misalignment. So whenever the shafts do have misalignment because of heavy loads, because of vibration, because of um, various reasons like the fatigue loading or the variable loading, we also need the bearings which are self-aligning in nature. So here comes the role of self-aligning bearings. So we are giving a larger amount of play to these balls so that it can take care of little misalignment. So if this is the midline, I'm showing this as a short break. Here the groove is of this shape. This is the ball somewhere here. So now this ball can move in this direction and it can take care of little misalignments in the shaft in the lateral direction or in the angular direction. And here there is a soft cushioning given. So this allows the ball to move, and this is a kind of self-aligning bearing. The image for this. Yeah, this is a double groove ball bearing, as I was telling you. For larger loads, for heavier loads, we need two rows of ball bearing, which can take the heavier radial loads. Yeah, this is about the double row self-aligning bearings. So you can see there are two rows of rollers, and these rollers or balls, they are placed in a zigzag fashion. So if one ball is here, another ball is here, and the third one is here. So it is attached, or they are placed in a zigzag fashion. And here there is a curvature given over here, and this curvature will allow the ball to slightly move from this position to this position. So this also accounts for heavier weights, heavier loads, and for little misalignment. That is also taken care of. This is the self-aligning. Sorry. Self-aligning bearing. Now let's talk about how these are assembled. Do you know how these ball bearings are assembled? Anyone knows about the assembly of the ball bearing? Anybody? No. Okay. So the first kind of assembly is known as a Conrad type assembly. And this is when there is an outer race and then there's an inner race, and this inner race is, say, shifted here. Yes. So the inner race is eccentrically placed, and we have all the balls, number of balls to be inserted here of same size. And then since these balls are very smooth, they are moved so that this inner race, this comes in between and the outer race is outside, and so that all these, the balls or the rollers, they form in a line. So this is a Conrad type of assembly, and another kind of assembly is known as the filling notch assembly. The filling notch assembly has the bearing, and in this bearing there is a notch provided in only in one particular area or one particular sector of that, and the rest of the notches are as usual. So there is a notch provided and all the balls are inserted only through this notch. This is slightly oversized so that the balls can be easily inserted, and they go on inside through this particular notch, say it is provided. Suppose here there is this enlarged notch. So balls are allowed to enter from here and then they are placed at their locations. And then this filling notch, this has to be sealed. This has to be sealed later so that the balls do not come out of it. So the advantage of this filling notch assembly is here more number of balls can be placed as compared to the Conrad type. In the Conrad type of assembly, you have to place some space. If this is tightly packed, then your inner race will not move and come in between. So you have to give enough space so that they align themselves, they fall in line or in this concentric pattern and allow the inner race to come in between. But here, every time a ball is inserted, it is placed in whatever location it has to go, and it can accommodate more number of balls as compared to the Conrad type of assembly. And another advantage is if the assembly is of this form as compared to Conrad type, this one has a better load carrying capacity. Again, this has been observed with statistics or with experimentation that this can take more load. But this has one disadvantage. Can you point out what would be the disadvantage here? So there are two advantages of filling notch type of assembly over the Conrad type of assembly, but then there is one limitation. Can you guess? Daitwa? Sarthak? Stress at the notch? No. Lower strength at the notch? Not exactly. Yes, any more guesses? Shifting of what? Ventilation, center of mass. No. We are designing these ball bearings to take into account the radial loads and the axial loads. If the assembly is created with a filling notch, then this has a limited capacity of axial load, or this is normally not used for axial load. This limits the axial load. Since the balls are placed along this axis in this direction, if there is a load coming in the axial direction, in whatever direction, there's a chance that the locking thing that is given in this filling notch, this might break and the balls might start coming out of it. So that limits the axial load. So if you are designing or if you are using a bearing for radial as well as axial load, then you have to go with the Conrad type of assembly. These are the textbook methods of assembly of ball bearing. I'm sure these days there would be newer and newer methods of assembling the ball bearing. Every time a new technique comes in the market, it is patented, and so it is not publicly available many a times about the new ways and new techniques. Yes? Yeah, somebody's asking something. So what is the basis for deciding what bearing should be selected? What should be the size of the groove or how much load it can take? So normally there are two governing parameters. The type of the bearing that is used, the type of bearing when I say whether it is a single row or whether it's a double row, self-aligning or angular contact. So the shape of the groove, the size of the groove and the type of the bearing. This will decide what should be the direction of the load. Direction of the load when we say it is axial or radial or ratio of axial and radial. And the load carrying capacity is dependent upon the size of the ball. So we have different ratings or nomenclature for the ball bearings, and depending upon what is the size of the ball, accordingly we have the load carrying capacity of a bearing. So we'll quickly see what is the nomenclature for ball bearing, and then we'll talk about why there is a limitation to the load carrying capacity or what happens if there is more load. So let's talk about bearing designation. Please draw along with me. I'm drawing a shaft. If this is my shaft, circular ends, there are 5 series of bearings depending upon the size and the diameter. I go on increasing the size and the height and the diameter of the balls and the outer rays. The inner rays, inner diameter is same, which means the bore diameter of the shaft diameter is same. This is 1, 2, 3, 4, and 5. One is extra light series. 2 is light series. 3 is medium. What is 4? Heavy. And what is 5? Extra heavy. So what do you mean by light or heavy? What is light or what is heavy here? Ajinkya, Manish, Ambika, what do you understand by the term light, medium, or heavy? Load and weight, yes. So it's load taking capacity or the load carrying capacity. So from 1 to 5, the load carrying capacity is increasing. This is in the order of increasing load carrying capacity. The shaft diameter is same for all of them. Look at this, the shaft diameter is same, and so it is drawn or presented like this. Same bore diameter. So as the bore size changes, this will again change. So here we are comparing it for the same bore diameter. This is extra light, light, medium, heavy, and extra heavy. So a bearing would be designated like 0, 2, 1, 4, or 1, 3, 1, 5, something like this. So there is always a 4-digit designation. And what is the meaning of this? 1, 2, 3, and 4. So first one, like 0 is indicating deep groove ball bearing, 1 or 2 might be indicating a roller ball bearing, or 3 might be indicating an angular contact ball bearing. So different standards will have different coding for this ball bearing. So in PSC design data book, when we are following AFBMA, which is Anti-Friction Bearing Manufacturing Association, the coding is different. If you try to follow ASME, the coding would be different. But depending upon which data book we are referring to, they will mention what code they are using. And normally the first one is indicating the type of bearing. So the type of bearing is whatever we have discussed. Normally 0 is indicating a single row deep groove ball bearing. So 1 might indicate a double row, 2 might indicate a triple row likewise. The second digit, whether it is 2 or 3, this is talking about this series. So if this is saying 1, this is extra light. So 2 is medium, 3 is heavy, and if it is 1, 2, 3, 4, 5 would be extra heavy. So this is talking about the series. So designation will vary only from 1 to 5. And this is talking about the bore size. Now, all possible machines will not have the same shaft diameter. So as a shaft diameter changes, the size of outer rays, the size of the ball, everything would change. So these last two places would indicate what is the size of the bore. Now the size of the bore and the diameter of the bore This is again having a relationship. If the size of the bore, design data book will normally give you the size of the bore. If the size is given as 0, 0, it means it is having a diameter of the shaft 10 mm. You will rarely have a shaft of diameter less than 10 mm. If the size of the bore is 0, 1, then the shaft diameter is 12 mm. For 0, 2 and 0, 3, this is 15 mm and 17 mm bore diameter. And the size 0, 4 onwards, if it is 0, 4, then it is size multiplied by 5. This much in mm. So for 0, 4, the diameter is 20. For 0, 5, what will be the diameter? 25. For 0, 6, it would be 30 mm. Likewise. So after this, with change in the bore size, the diameter increases by 5. So 0, 0, 0, 1, 0, 2, 0, 3, this is 10, 12, 15, 17. And from size 0, 4 onwards, we get the diameter of the shaft or the bore, which is size multiplied by 5. So if I am giving you a rating 0 to 1, 5, where 0 is indicating a single row deep groove ball bearing. What is the meaning of 2? This is which series? What do you mean by 2? This is light series. And what do you mean by 15? What is the diameter? If the size is 15, the diameter is 15, 5 is 75 mm. So it is 75 mm bore diameter, light series and deep groove ball bearing. So when we are designing, you would know the loads because you know what the shaft is carrying. You would know the distance between the bearings and you are required to select a bearing. So for selecting the bearing, once you have the diameter, based on what is the load for that diameter, if you have to select the series, you have to select the type of the ball bearing and check what is its load carrying capacity. And the load carrying capacity of the bearing that you have selected should be definitely little more than the load that the bearings are subjected to. So how do you find out the load on the bearing? It is the reaction. When you are designing a shaft, and we consider this as a beam which is subjected to a load, here you have the supports which are nothing but the bearings. To find out what are the loads coming on this. So this load would tell us what kind of bearing we have to select. So this load that you know and the load carrying capacity of your bearing. So this load carrying capacity should be greater than this load. So what happens if it is loaded heavily? Suppose the load coming is more than the load it is subjected to. This would be subjected to contact stresses. What is the difference between compressive stress and contact stress? Another important question for our interviews. Difference between contact stresses and compressive stress. Anybody can tell me? Collision? No. Collision will lead to impact. Ujjwal, Aditya, Richa, Anybody can tell me what is the difference between contact stress and compressive stress? Impulsive stress in contact. Impulsive is from the term impulse, coming for a short period of time. Is this what you mean to say, Prajwal? Okay, yeah, localized stress is correct. Continuously applied, like stress applied by the road on the tire, yes. Okay, so a compressive stress is, so this is the column and this is subjected to a continuous load. Whatever, this load might be because of some beam, a heavy beam over this. This is causing a compressive stress. Static compressive stress. A contact stress is normally, yeah, this is a good example, like the stress applied by the road on the tire, where this tire is in contact with the road for this particular area of the tire is in a contact with road for a small moment of time. And since this is continuously rolling, next time the contact stress would emerge here, next time the contact stress would come here, and then here, and then here. Likewise, all these balls and the rollers which are placed inside the races, when they are coming in contact with the inner race or the outer race, the type of stress that is coming into picture, this is known as contact stress. And a detailed study of this contact stress was done by Hertz, and so we call this as Hertz contact stress. And for the bearing again, this is the outer race and this is the inner race. When a ball is here, the maximum amount of contact stress will occur little inside its circumference, somewhere here. Not exactly at the surface, but radially inwards towards the center. So what we understand from the Hertz contact stress is, if there is a point contact, which means the area is very, very small, this would lead to infinitely high stress. Infinitely high stress. And because of very heavy stress, now there is nothing like infinite when we talk about calculations, but a very high, very, very high value is known as infinitely high stress. Now what would happen because of very high stresses? This will lead to wear of the ball. So ball will undergo a lot of wearing. And because of this wear, what normally happens with the tires on the road, same thing would happen here. You know that these tires, they'll have some projections, some different design, and each company of tire will have a different projection or a different design. So from the design, they would normally the employees of those company, they would tell us whether this is JK tire or MRF tire or whatever brand of tire they are using. So what happens with continuous use? What happens to the surface of the tire? Vedant? Looking at the surface of the tire, the experts, they can even tell you or guess how old is your vehicle. So there would be flattening of the tires, the projections on the surface or the design on the surface that would wear away. And this would lead to flattening of the tire. Likewise here, because of the high wear of the ball, there would be flattening of the balls. So the balls which are perfectly circular, they slightly become flat. So again, on an exaggerated view, if this is a perfectly circular shape, somewhere here I'm showing flattening. Likewise, after a period of time, this will become flattened, and with flattening, the area would increase. And as the area increases, the stress reduces. So when it's very new, there is high wear and tear, and the moment it becomes a lot of time. So if I again exaggerate this, this is known as crack propagation. So this crack will start propagating towards the surface. So the crack starts from a deeper surface. It doesn't start from the outermost surface. So it starts, the crack would appear at the surface little inside the outermost surface. And this is how it would normally fail, and the moment a crack appears here, it has to be completely replaced. To avoid this, because we know that this will develop a crack on its surface, how do we avoid this? Case hardening is done. So case hardening is where only the outer surface of the crack of this ball, this much thickness, which is just the outer case, this is hardened. So normally case hardened chrome steel is the material used for balls and rollers. Next class we'll talk about roller bearing. So it's a case hardened chromium steel which is used for the material. Lot of heat treatment is given to improve the strength, to improve the hardness. This is improved with heat treatment, which stays heat treatment here. And all these ball bearings, they are designed for a finite life, and the life is always given in number of cycles, a number of revolutions. So while we are designing, we'll discuss in the next class how do we find out the life of a bearing. And the life of the bearing would depend upon two parameters. One is the speed in which this will be rotating and number of hours. So from the RPM, we can find out its life in number of hours. This is how the finite life of the bearing would be defined. So next class we'll talk about different types of roller bearing, and we'll find out how the life of the bearing is calculated, what are the different terminologies used for ball bearing, roller bearing, few formulas that will be required for designing the ball bearing, and then coming lectures will solve numericals on the ball bearing using both the design data book, B.D. Shivalkar and PSG design data book. So that's all for today. Let me know if you have any doubts. Any doubts? If no, then you are free to leave. Thank you, everybody.